Okay.
Okay. Welcome to today's DRA Carpenter conversation on behalf of SIG Autoscaling and the Carpenter Project. We are part of the CNCF and abide by the Code of Conduct. Take it away, Jason.
Sure. So I do have the initial, I guess, RFC that I got up for the node overlay integration. I'm still working on fleshing out the finer details of it, so it is a whip right now, but I think it should hit the high level points. And if we want to see if we can align on some of that today, I think that would be a good place to get to. So I got it up 20 minutes ago, so I'm not expecting anyone to have read it yet. But I guess so at a very high level, I guess I can go ahead and share screen too and just bring it up. Okay. So at a high level, what this goes through is it just gives a little bit of background on what node overlay is, why we needed it for standard extended resources, and how it makes sense as a model to extend to resource slices. Lays out some non-goals for it. The main thing I called out at this point is I think theoretically you could have resource slices that are provisioned that aren't hosted by any instance. So if you had like a network attached device that isn't associated with any given instance, it's provisioned onto the network in some other way. Like maybe a little bit of a silly example, but let's just say an IP camera. Um, I don't think we're going to be looking to support anything like that, at least initially. At the end of the day, Carpenter being a node auto provisioner, the thing it's going to bring up and that it needs to understand the resources that are available for it are nodes and instances. So having this one-to-one mapping between resource slices and instance types, or not one-to-one mapping, but I guess many-to-many is what node overlay enables. Um, but yeah, I think it's appropriate for our goals. And then for general API shape, what I basically laid out three different options that I think we have for embedding this into the node overlay schema. The first one just being a list of unstructured objects. The second one just being a direct copy of the upstream V1 schema. And then the third one, and the one that I'm recommending, is a custom schema, which we might call something like resource slice template. And that schema is scoped down to the specific fields that Carpenter supports. And what I'll propose later is also uh, extending it to support some of the additional information that Carpenter needs to be able to encode. I don't know if we want to take some time to just read this or if me continuing to just kind of read through it and give an overview is a good use of time.
I think this works for now. I'm going to probably take some notes and I'm going to like just that those three options I'd love to add Kuba to see what informed his thinking when he was the primary engineer who did this in cluster autoscaler, how he came to us. He probably would have been faced with a similar concern.
I'm curious though, with cluster autoscaler, I don't think they support scale to zero, right, for DRA. Like it requires that a device came up for a node group and it assumes that as you scale the node group, the resource slices will also scale linearly.
As of now, that is true. Scale to zero is a kind of provider specific solution for cluster autoscaler. So the cluster API um, provider is a sort of prototype of how it might work with cluster autoscaler because you can it defines a set of well-known metadata that you can decorate the cluster API like node group abstractions, which are things like they're called machine deployments or machine pools
Mhm.
that can represent um, scale informing metadata like CPU count, memory count. So something like that could also be used for resource slices. But as of right now, that's not a thing. There's no scale to zero story
Got it.
as of right now.
So it does sound like that does play a similar role then to what node overlay is playing the Carpenter ecosystem, which is, I mean, in our case, we do have like a default set of assumptions for this instance type as this many CPU, this much memory, etc. And node overlay allows you to provide the overrides. But yeah, so I guess continuing on with this though, based on this recommendation, I also had basically the list from the 134v1 schema of fields that we would not support. So some of these are ones where it's just not supported because it doesn't make semantic sense for Carpenter. Node name, for example, being one of them. The node name isn't something we can concretely know at the time that we're creating the node overlay because the node hasn't been created yet. So semantically, what I think we would want to do is if you're creating a resource slice, which is only going to be node local, you just don't put a node selector in the resource slice and it assumes that it will be node local. And by it, I mean Carpenter. Similarly with pool, none of the pool information, I believe, is relevant for Carpenter scheduling simulation. So I think omitting it makes sense, just because there's no benefit to a user providing that information, and it could cause some amount of confusion if there's information that you're providing in the template that doesn't actually do anything. And then the final ones were just all of the alpha fields. So the one thing I was a little bit confused by though was some of the fields, which as far as I'm aware, are backed by alpha feature gates. So those being shared counters, capacity, and consumes counters aren't actually marked as alpha in the schema, like in the description of the fields. Whereas like binding conditions, binding failure conditions, all of the other ones that are backed by alpha features are like does specifically say this field is alpha, it's backed by this feature gate. I don't know if this means that even though the feature gate is alpha, we're committed to this API, or if it was maybe just a miss or inconsistency. That would be a good thing for us to clarify.
Yeah, could you provide a link to the reference that you deduced that from, and I can pass it along to the relevant DRA maintainers.
Sure. Yeah, it's from the like swagger.yaml.
Yeah, I mean, I assume
Yeah, it's back.
we'd look at the same, but I'd love to see exactly where you
But
saw that and then just pass it on.
yep, yeah, I'll send it your way. I have a custom build of this like manifests.io website I've been using. So I don't have a public link, but I'll figure out a way to get one. Worst case, I can just link you this Swagger doc.
I see. Cool. So you're you are you should consider. I don't know what SIG that would be a part of, but that might sounds like that would be generally useful to the Kubernetes ecosystem if there were a handy auto-generated web interface to declare to define the API.
Well, this is one I just found kind of recently. I don't know if it belongs to a SIG or if it's sponsored by the CNCF or anything. But it has the schemas for not just Kubernetes, but a fair few associated projects. So I noticed they didn't have 134. I'm getting a PR up to get 134 into there.
Cool.
But but yeah, so I think the final thing, which might be the most contentious, is how we want to support these like relative topology requirements inside of node overlay. So I know we have talked about this in previous weeks. The issue that we're trying to solve is that when you specify like a node selector, like let's say you want to have a resource slice which can be consumed by any device that's in the same zone as the host instance. I think zone is a realistic example. Like for example, if you wanted to model in EC2, if you wanted to model EBS volumes behind resource slices, resource claims with DRA, they would be zonally constrained. Um, we don't have a way to express directly that we don't know what zone the resource slice will be in available yet, but we do know it's going to be whatever zone the instance is provisioned into. But we want to leave Carpenter with the flexibility to choose what zone to provision the instance into. So I had a couple of different ideas for how we could, or I guess to start, does that use case make sense? Any questions on why that's something we need?
Oh, it makes sense to me.
Okay, cool. So I had two different proposals for this. Originally, I was thinking we could do something like a CEL expression. So this was just the example I came up with for what this could hypothetically look like. Is like you just have this resolved label function, and Carpenter knows to interpret that as this field selector is going to be whatever this label ends up resolving to. Um, I think that's I think it ends up being a little bit too flexible for our use case. Like there isn't anything else I can imagine you wanting to use CL for here other than this particular, I don't know the label yet, but it's going to be whatever this value is. So I realized though that this is very semantically similar to what we introduced match label keys for pod affinity and topology spread constraints. Specifically for that, people wanted to set up like topology spread constraints based on the pod template hash, and you don't know what the pod template hash value will be until the deployment, or I guess the replica set controller creates the new set of pods. So my thought was we could basically just mirror that API design and extend node selector. So right now it has like match fields, match labels. This should be matched, or sorry, match fields and match expressions. And we would extend it to also have match label keys. So this would mirror that existing API on the pod spec for both pod affinity and for TSC. And I like this a little bit more than the CEL approach because it it's focused on the specific use case we're trying to support without being overly flexible. And then it's also not a one-way door decision. Like if there were use cases to have cell expressions for these match fields, match expressions, we could add that down the road. But right now, given that the flexibility requirement isn't there, I think it makes sense to punt. Guess any thoughts on that?
No, this is probably something I'll need to take in a little bit more, but
Yeah,
I'm
that's fair.
I'm listening in.
Mhm. Yeah, I did go in to discuss some of the scheduling semantics of this as well. I may end up just separating this out from this RFC because I imagine what I'm going to have is two RFCs. There's this RFC, which is like the user API surface, and then a separate one for the actual lower level implementation details, like how it integrates between the cloud provider, the scheduler, the node lifecycle controller, or the node claim lifecycle controller, not to be confused with the KCM controller, etc. But
So
yeah,
I think what I would love to see is a simple end-to-end flow of how a pending pod with a resource claim that is looking for a particular device with particular characteristics, how that uh, how Carpenter creates a corresponding match with a node overlay resource with the corresponding resource slice information and
yeah,
the whole thing. Like, so a node overlay object is going to include not only just the resource slice metadata, but all the other like like you have in your top example there. You've got the instance type and all that kind of thing. So that would be, I think, super helpful to.
I think I kind of have that a little bit in my RFC, where I have the high level overview of the node overlay case.
Okay,
This
cool. I
is
mean, maybe that's a second RFC because I know that this is sort of phase zero, just integrating resource slice into node overlay and less about integrating DRA into Carpenter. Is that fair,
yeah.
Jason?
My intention was to put something like that in that second RFC.
Okay, cool.
Admittedly, the line between what should be in like this one and what should be in that one, or should they just be one RFC, is a little blurry.
Yeah, cool. So the key questions are really, I think we're all aligned that integrating it as a set, as an array, even though that's somewhat academic at this point, but we want to cover the one-to-many case for node to resource slice. So that's,
Yeah.
I think, a +1. And then how do we model it in Carpenter as a strongly typed property for node overlay, like those sort of three options that you laid out. Yeah, those are the two key questions for me, I think.
Yeah. Yeah, and I think the other question for me is just how do we support this relative topology requirement? Because it's not
Yeah.
something that you can really express in the upstream resource slice resource. And I also don't think it's something that makes sense to express in the upstream resource.
Could you add some use case input for relative topology from a workload point of view? So like what does relative topology look like
Yeah, I
going
was
into the
trying,
system?
yeah, I was trying to find, I'm pretty sure that like with NVIDIA's compute domain driver, it would make use of this because I think it has a selector and click ID.
Yeah.
I was having a hard time trying to find a concrete example of what the resource slices created are, because they have their compute domain abstraction on top of it. So I'm still looking into that. I do want to include that concrete example of this is what this looks like with a real driver that exists.
Cool. We can get that. So you just basically want a resource slice that maps to a node or a rack?
Um, so in this
Actually, there
case,
isn't. Is there one that map? I don't think there's going to be a rack resource. So that's what a compute domain is. That it abstracts away.
yeah, but a compute
Uh,
domain, you have resource slices that are provisioned under the hood for it, I believe.
yeah.
So I'm getting I saw that with their driver, you could set up in a kind cluster and get it do some simulated examples. So I was working on getting that set up. I
Cool.
didn't.
Yeah. Wouldn't it be nice if we just had a GB200 that we could
Oh, I
copy and paste
wish.
from?
Yeah. I haven't asked. Maybe they'd give me one, but I kind of doubt it.
Wait, so question with doing like having a custom resource slice type in Carpenter, would that also mean that we would use that for all cases, not just node overlay? We would also use it for config map.
Um, More than likely.
Yeah.
I mean, that being said, the custom type isn't really anything. I don't want it to diverge significantly from the upstream type. Like I think that would have to be a tenant is that anytime it diverges from the upstream type in a way that's not just making it a subset, like that needs to be heavily scrutinized
Yeah.
because ideally customers like they should be able to look and say, okay, I've got a node. This is the resource slice I published. Let me just copy paste that into the node overlay for that instance type.
Yeah.
Um,
I'm just with like I already started implementing the config map, so I'm just wondering if I should like right now I reference like upstream resource slices, but I just have to keep in mind that maybe later we'll edit that to use this custom type.
if
That's
it does end up being a change, it's not going to be a very large one. The
okay.
only the only place I see it, and for honestly though, the more I think about it, I think it probably makes sense in your case to use the upstream resource. The reason being, some of these fields that don't matter at scheduling time, or at least not necessarily at scheduling, but when Carpenter is making its choice of instance types. So scheduling in the Carpenter sense, not the kube scheduler sense. So things like binding conditions, binding failure conditions, binds to nodes. We may still want to be able to express that in the custom like test driver, but we would not have a reason to embed that into Carpenter CRD
Um,
because they're irrelevant to how Carpenter selects an instance type.
yeah. Okay. That makes
That's at
sense.
least my thought at the moment.
Okay. Okay, cool. Yeah, I need time to read this separately, and
Yep.
if I have questions, I think I need to do this asynchronously.
Yeah, that's reasonable. I
mm,
got it up very little before the meeting, so I didn't give a chance. Yeah,
oh,
I didn't really have a chance to let people know and see if people could read it beforehand.
this is nice though. Thank you.
Mhm.
Um,
Yeah, there are some other, like I said, I do still have this marked as a draft. There are more things I do want to include in this, which is like that concrete use case and a concrete schema example. Um, a definition for you can have different node overlays of different weights, and there's conflict resolution between those weights. So a definition of how we handle resource slices and that conflict resolution. And then also just the final thing is how this integrates with Carpenter's node claim initialization check, which is basically given Carpenter's expectations for what resources are available on an instance type. So whether that's from the cloud provider or from node overlay, we won't mark the node claim as initialized until we see that all of those resources are there. Since the resource slices that are published by the driver are presumably not going to be one to one the same with what's on the node overlay. There's a little bit of ambiguity in terms of how do we decide if the resource slices we expected to be provisioned actually were provisioned. Like, how do we say these two things are semantically either the same or close enough? So, yeah, those are kind of the three final things I wanted to include in this RFC. But if there's any suggestions for anything more you would like to see, I'm happy to incorporate that.
Cool. Great. Great start. Great progress. And I know you're still on call for 2 more days, so nice done.
Oh,
Nicely done.
no, I'm not. It was
Oh, you're
last.
not. And oh,
Yeah.
yeah,
The way
time's a
our
flat circle. I can't keep track.
yeah,
Congrats
no,
on overcoming that.
I appreciate it. Yeah, the unfortunate thing is it always drags a couple of days after your on-call week. So really my first full day off was yesterday, but
oof.
just wrapping up ops reports and such. So, but I don't have it for a while, so I should be able to be full steam ahead on this. Yeah, definitely going to aim to have this complete early next week. Aim to start getting that implementation RFC up by the time we meet next week as well. Which I think should be realistic.
Mm.
So, because I have it all scratched out, it's just getting it into a presentable format.
Okay, great.
I can
Lima, do you have any questions?
my stuff. No, I definitely will have questions later, but high level overview, I'm understanding, and it all makes sense to me. But I want to like deep dive into that later.
For sure.
I have, so I'll just show. I
It
didn't
should
put
be,
the
if you don't have screen share, I can make you co-host.
Yeah, I can go ahead and stop sharing.
Looks like you might be, can you try, go ahead and try? Yeah,
I
you're
think.
good.
Yeah, so I just started the implementation for this. I didn't think about making another RFC. I kind of thought the RFC I made before describing the two cases was enough. Um,
I think so. I don't think we need another RFC unless there's something you think we need it for.
uh, I don't think so. It's just kind of big, like really big. But I think it's because I was also generating tests for every file I was making, which I don't think it's really necessarily necessary. But high level overview, and you guys can take a look at at this more when I finish fleshing this out. But in here I basically start like create the config map and resource slice controllers. So then in the package directory in controllers, I have the config map controller, then resource slice controller, and let me see my notes. Yeah, but the actual integration tests here will create they'll create the config map, and then this will actually watch out for that specific config map.
Mhm.
With that, in types.go, it'll parse that config map YAML and make it into an actual Go struct. And from there, yeah, and then from there we have the resource slice controller, which will also watch for the Quark node being created, and then create the resource slice. And then this will all check that the resource slice is created. Yeah, I'm still going through this, but that's a high level overview and I'm editing this as I go. Yeah, the main concern I have is this is kind of getting big. And in terms of review, I don't know.
Yeah, and this is something we're still trying to figure out the best way to approach. I don't know if there's maybe some settings we can do in our repo to make feature branches a bit of a better experience. Um, we tried to develop static capacity off in its own feature branch and just keep rebasing main onto it, and had a tough time with some of the CI actions.
I think you're actually going to be okay, Lena, just because most of this is net new code and it's test code, so it's somewhat isolated.
Yeah, it should be fine. I'd just recommend not rebasing and force pushing when you do new changes. Just because I found for large PRs, like GitHub's diff detection isn't great.
Yeah,
Like if you squash your changes onto an existing commit, it's not always going to actually be able to show what's changed between revisions.
I see. Um,
So,
so you're saying don't rebase off of main?
or you can rebase, but I wouldn't squash your commits together.
Okay.
Like keep separate commits between reviews if we think it's going to get difficult to review.
Yeah,
I think
I
though,
know.
given that it is mostly new code, that's new code is much easier to review than large changes to existing code.
Mhm.
So
Yeah,
like,
and you can always replay. I mean, if yeah, the in my experience, optimizing commits as part of a review, like telling a story for the reviewer as a sequence of commits, it's super hard to anticipate that like in real time ahead of time. So usually you would end up replaying the whole thing, like
Mhm.
checking out your branch, pushing everything out of a commit, and then creating a series of commits that tell that story at the sort of end when you're ready for a reviewer to take over.
mhm.
Mhm. Okay, I'll keep that in mind. Yeah, I might just have to squash some commits to make things clean, but keep it separate commits.
Yeah, I mean, it's less so for the initial set of commits. A clean set of commits
Right.
initially that you're squashing together is totally fine. And yeah, I guess it depends. What I found, what I miss from like for Amazon, we have our own internal code review system. And we can see like when you push up a new revision, you can see the diff between that and the old revision. And as
Wait,
far as I know, there's no real way to do that with GitHub.
like, are you saying between commits?
Uh, yeah, pretty much they're not commits. It's like the problem is what I see from a lot of people is they will keep their PR one commit, and then when they get changes, they just do a git commit amend and then force push. And
Oh,
then it becomes very difficult to tell what they changed, what they didn't.
okay.
So
Yeah, and again, and so what I was saying is that's totally understandable. If that helps you better organize your code or better execute a rebase during the development process, what you can do is when it's ready for review, is you can essentially squash everything into a single commit and then do a kind of undo the last, like go back in time one commit and then move all of the changes in your last commit into your sort of dirty git context, and then
Okay.
you can add and create commits in an order that's optimized for consumption by a reviewer who's looking at it for the first
I think
time.
you can do a diff between multiple commits though.
you can't, the issue is when there was a review and then you squash after that review.
Oh, that's definitely yes. So
I see. Okay.
that's why yes. If you have a whip, if you have a PR marked as whip review at your uh, uh, I can't think of the expression. Anyway, yes, exactly. Because as you say, Jason, it's totally plausible that someone would totally rewrite the whole thing, and then that conversation becomes it's orphaned in terms of a reference to an actual SHA.
Yeah. The main thing that I've found difficult, and I have to kind of repeatedly ask people to do this on large PRs, is once it's out of a whip state and we're doing final review, and there are a large set of requested changes, and then all the suggestions get squashed. And then
Yeah,
it's
yeah, yeah.
really difficult to tell, like, okay, this is a 5,000 line PR. Did you actually change everything that needs to be changed?
Yeah.
So, but yeah, no, during the actual development process, do whatever you like with your commits, whatever
Mhm.
works best for you.
Yeah, and also it's also ideal for that to just have a post merge, or I should say post approval pre merge squashing happening by
Mhm.
CI, so that you
Yeah.
know you don't get
I
a
like that
review and
squashing.
then squash at the very end, and then lose all of the historical context in the
Yeah.
review.
Yeah, we do have squash and merge enabled on our repo by default.
I think I'm almost done with this. So I'll just ping you guys to take a look at this.
Okay, sounds good. I won't be around tomorrow, but next week, I'll be able to take a look.
Um, yeah. And any progress with the scheduler allocation?
That's what I'm working on writing up. So
Oh,
the answer is yes.
okay.
But yeah, I didn't get a chance to finish writing it up. So
Mhm.
so yeah, I should have something written up by the time we meet next week.
Okay, perfect. Um,
Uh, yeah, had to make some compromises. Um, but I think what I'll be proposing is more than sufficient for a first approach. I think the reality is we'll probably have to have a caveat on DRA for at least a little while of this may not perform at your 50,000 node scale.
uh-huh.
All of those devices or all of those nodes are publishing resource slices.
Mhm.
Um,
That's fair. Yeah. I mean, that's sort of true with DRA and core Kubernetes as well. I know it's been
no,
reported, so someone might be mad at me for saying that, but
it's
um,
called out in the comments in the allocator. It's
to,
doing
to
an
a certain yeah,
search.
to a certain extent, we're just now getting some really good mileage on 5K node cluster tests using various bits of DRA functionality. So
Yeah. Yeah, it's definitely been a push for us as of late is increasing our scale. I mean, we've talked about like we did had the announcement for EKS Ultra Scale for 100K nodes. And yeah, we're just going to have to call out this is not going to work at those scales. Um, you can use other Carpenter features at that scale, but not this. Because for us to do it optimally, it's even worse than upstream because when they do the DFS through like the whole tree of devices that you can allocate, you can just quit when you find the first result. us to ensure that we're like making optimal selection, really want to find all possible results.
Yeah, and that's called what you point out is called out as it's a current gap in the DRA functionality. So
Yeah. So,
like
but yeah,
prioritized alternative is not prioritized really yet. That's TBD.
yep. Yeah. Yeah, no, I went through and read all of the issues about like weighting. Yeah, basically doing scoring for DRA and why that wasn't feasible at the moment. So, okay.
Also, sorry, last thing. You were talking about the conflict resolution for node overlay. That's like one
Yeah.
of the things you have to deal with for research slices. Um, I thought the conflict resolution for node overlay was that when there was a conflict, they just don't apply.
Yeah, the question is, what is a conflict
Oh, I
for a
see.
resource slice?
Well,
So
this, well,
I'm kind of thinking the approach is going to be there are no conflicts for resource slices. All of the matching resource slices are appended together. Um, I think because there's no key to do a conflict on, if that makes sense.
mhm.
Like, you don't want to do it on driver because you could have different resource slices produced by the same driver. Um, if you really wanted to add a use case for it, maybe you do it on metadata.name. Like, you allow customers to kind of define, like, this is the key to detect conflicts on. I don't know if there's a strong use case for that. It's something we could always go back and add if presented with one. Um, so yeah, I think when I said it's a to-do, I more so meant it's a to-do to just think about it a little bit more, make sure it's reasonable, then get it written down. But I think as far as conflict resolution goes for resource slices, yeah, it's just append all of them together.
Okay.
Um,
Um,
for the most part, I don't expect overlapping node overlays for like, I wouldn't expect too many users to be defining multiple node overlays that apply to the same instance type that publish resource slices of like the same type.
but I think appending all of them together makes sense because they do that for capacity. They just merge everything together.
Well, capacity still has some form of conflict resolution because you're looking at the resource, like the extended resource type.
So, what do you mean? Wait.
So for example, if you have a higher weight node overlay that applies a NVIDIA GPU, and then you have a lower weight one that applies an NVIDIA GPU, the higher weight one is going to be the one that's used.
Mm-hmm. But
Rather than like us summing together and now saying you have two NVIDIA GPUs.
okay,
Um,
I
whereas
see.
with this resource slice one, it would be if you have a higher weight node overlay with like a NVIDIA GPU resource slice and a lower weight node overlay with an NVIDIA resource slice. What I'm proposing is we just merge them together
Okay.
because I don't think there's quite the same key semantic to merge on. That's one I have to think a little bit more about. Um, Part of me thinks just stick with the simplest version to make the merge semantics easy to understand, um, rather than trying to do something complicated to detect like if two node over or two resource slices are similar enough to be in conflict.
Mm-hmm.
Um,
Yeah.
but yeah, no, I'm definitely open to other opinions on that. I think realistically, though, it shouldn't matter too much because the main reason we anticipate people applying multiple node overlays to the same set of instance types is because they might have one for capacity and they might have one for price. Or maybe they have like a node overlay for I want to say all of the um any instance with a GPU is time sliced, so I want it to actually be advertised as two GPUs. Um And then you might have another one that conflicts on a different resource where it's like, okay, I also want all of these instances to have huge pages. So that's more so the use case for having the overrides. We don't really anticipate there being a strong use case for having these overlapping node overlays where resource conflict resolution is required. It was more so because we were defining this weight mechanism for other non-conflicting purposes. We still had to define the conflict resolution mechanism. That actually ended up being probably the trickiest thing to get to make it easy to reason about in node overlay was figuring out that conflict resolution mechanism, which is why I don't want to overcomplicate it for this.
Yeah. Also, last thing, when I'm implementing the config map case, should I use V1 or V1 beta 1 for resource slices?
I think V1. I don't think we're going to try and target support for V1 beta 1. But this is something I need to learn a little bit more about how Kubernetes does like API graduation. Is there a reason all these different versions coexist outside of migration? Like, is the anticipation that the alpha and beta APIs will continue to be developed with incubating features that then graduate to the V1 API? Or is it they just stick around for migration and eventually the V1 API will be all that's left and development continues to happen in the V1 API? It seems like it's the latter.
Yeah, like the old ones get removed or deprecated later.
Are we talking about the V1 alpha, V1 beta representations that are part of the original introduction of a particular alpha feature?
Yeah.
Yeah. They're always, I'm not sure they're actually ever removed. It would be in a far future version. I'm not sure that's a regular part of the Kubernetes API expectation. That's a sort of infrequent thing. But I'm happy to sync up with see how this replies. DRA is somewhat of a extreme. It's really like a stress case of the API contract because there are so many features moving at a slightly different velocity that will all eventually converge into a common API.
Yeah, no, I listed down all of the feature gates that are currently merged, and there's 4, 5, 6, 7, 8, 9, 10 feature gates that exist today. Not to mention all of the other caps. And that's not even counting the DRA feature gate. That's 10 on top of DRA.
I'm just thinking about KK actual hygienic PRs that remove APIs from the schema. I think that's an infrequent event.
I mean, I think it's reasonable regardless for us to only support V1. I'm more so asking out of my own curiosity, like, so I know we have alpha fields and beta fields on V1 APIs. I'm just wondering if there's a reason why the process isn't like instead of adding these alpha fields to the V1 API, keep them on an alpha API, maybe a new version of the alpha API, and then graduate them to the V1 API when they actually become stable, and just make the V1 API the stable fields.
I think that is the idea. I didn't hear anything that you said that contradicted with the Kubernetes API, as I understand it.
Well, I've seen things like, for example, in pods, they added alpha and beta APIs to the V1 pod spec. Same with, same with DRA right now. They're alpha.
Oh, I see what you mean. So you mean when there's a contradiction in terms of composing multiple APIs in like the mutual compatibility with like the V1 sort of parent API with a set of pre V1 like child properties is confusing. I see.
Yeah, I think it's been something we've been kind of thinking about in terms of how do we do like node overlay feature development. we want to get a stable version of node overlay out relatively quickly. But we also want to be able to keep iterating on these extensions. And the question is, well, is it confusing for users to have these alpha fields on a stable API versus just have the alpha fields on the alpha API? And if you're using anything on the stable API, it's stable.
Yeah, I don't know the answer. I can't answer the user question
Yeah, it's
for
something
you,
I'll
but
probably raise in API machinery. I'm just curious about, that's probably the right place I'm going to guess.
I mean, ideally, users just don't care about that stuff. Like they might care about features in terms of feature gates. That's a reasonable expectation of a user. Like turn this feature on with this
Sure.
well-known feature gate configuration. But burdening a user with like, okay, when you declare your particular resource, if you've engaged that feature gate, then you need to use this API version. If you've not, then you need to use this other API. That would explain, I think, some of the mutual compatibility that may, from a logical point of view, seem contradictory, but from a user point of view is more ergonomic. They just worry about an API, and to a certain extent, the API is mutable in terms of its properties based on the feature gates that have been enabled.
Yeah. Yeah, no, I can definitely see both sides of the argument. I know it's caused some confusion for our users of, well, you said the node pool API is stable. Why did this field get removed? And it's like, well, that field was alpha.
Yes. Yes.
And it was marked as alpha. But
Yeah. Yeah.
yeah, no, I've been trying to track down some history around that, but that explanation does make sense to me. Yeah, I think unless anyone has anything else, I think that's about all I have for this week. We can maybe end a little bit early. Um, yeah, like I said, I'm going to aim to have this RFC basically fleshed out by end of day Monday. And then, yeah, hopefully get the implementation RFC at least to around this state where like mostly done, but still needs a little bit of polish by this time Thursday.
Great. Great progress, both of you.
Yeah, thanks. Yeah, let me know when you're ready for a first pass review on the driver. I'll be able to take a look.
Yeah, it'll probably be. Oh, I know you're off tomorrow. I'll ping you on Monday.
Okay, sounds good.
I think we can sync and talk over it together because it's a lot, I think. I mean, it's not a lot, but it's
Sure, I'll probably take a first pass first, just so I
yeah.
can familiarize myself with it. But yeah, I'd be happy to sync after that.
Yeah, same with yours. Because I think I'll have a lot of questions that I'll just compile as I read it.
Sure, sounds good.
Great. Thanks so much.
Yeah, no problem. I'll see y'all next week.
All right. Bye.
Everybody.